Okay, good evening. I hope you're able to get me and you're able to hear me clearly. Well, in this class, in this tutorial, we are going to look at tutorial sheet 1. Okay, let me display it here. So this is Cavendish University, Zambia, School of Medicine. That is here MSF program Mtm110 and this is semester 1, that is to say mathematics set theory tutorial sheet 1. So we're going to solve up to question 4, and the rest of the questions will be posted on the website. We can be able to access those on the website. So you see we have question 1 here, define a set. Question 2 is asking us, is 2 equal to the set containing 2? Then we're saying question 3 is, which of the following sets are equal? Then we have these sets here. We have to see which ones are equal. And question 4 says, consider the universal set U to be this 1 to 9. And the set A defined as that. Then we find the following: A intersect B, A intersect C, complement of A, complement of C, the symmetric difference between A and B and C. Then we go here, the set difference between A and B and C, set difference A, union C, B, and symmetric difference A, B, A, C, like that. Then we'll finish there. Then the rest you can access them on the website. Okay, so how do we go about these questions? So the first question is, define a set. So in the previous classes, we did define what a set is, and we said a set is a collection of elements called of elements or objects which we're calling elements. So it's just a collection of objects. Well, they have to be well defined. So let me state well defined objects, which we call well-defined objects, which we call elements, which we are calling elements of that set, or members of that set. So it's just a well-defined collection of objects, which we're calling members of that set, or it is a well-defined collection of objects which we're calling elements of that set or members of that set. So it must be well defined. If we're talking of numbers, it must be a set of numbers. We were talking about a set of fruits, it must be a set of fruits. There must not be any ambiguity to how your set is defined. It must be well defined. I must be easily able to identify that my set contains these elements, my set contains such members. So now the next question here then tells us, is 2 equal to the set containing 2? So now 2 is an what? 2 is a number. So this number we're saying is either this number is an integer, or you could say a natural number. No, it's just a number. Of course, yeah, an integer, natural number, of course. 2 is a natural number. It's an even number. It's a number, of course. So now we're telling us, is this equal to the set? So we said set shall be denoted using this these parentheses here. We shall use this to denote what a set is, and whatever goes inside then is a member of that set. So we see that here now we have this set containing 2. So we have the number 2 here, and we have the set containing what? Containing 2. So these are different because this cannot be equal to that. This is the number 2, but this is a set. It's just that this set only has one element, and that element is what? Is 2. So it's more clear if we say 2. Let's say 2 is equal to, and let's say we had two numbers, 2 and what? 2 and 3. You would say these, of course, are not equal. You already know. But the reason why we're saying they're not equal is because this is just a number and the other side is a set. That's the reason why they're not equal. And even in this part here, they cannot be equal because this is the number 2, but this is a set containing the number 2. Hence, they are what? They're different. The other one is a set, the other one is just a number which you've put on a list. So that's how we go about this. Well, on the next one, then they tell us to say which of the following sets are equal. Which of the following sets are equal? First of all, we must understand what it means for a set to be equal. So we say a set is going to be equal. Let's say A is going to be equal to B. The set A is going to be equal to B if every element of A is in B and every element of B is in A. And of course, that just means that A is contained in B, and of course, B being contained in what? Being contained in A. Then we would say that A and B are actually what? Equal sets. So if A is contained in B and B is contained in A, then A and B are going to be equal. It means that they have what? They have the same number of elements that are there. So now how do we go about this one? So when you look here, we said a set is just a well-defined collection of objects known as or called elements or members. And a characteristic of that set is that it must have distinct what? Distinct elements. Distinct elements, what I mean is, so you look at in our case where we have, okay, let me say in the set B, we have this elements, there's Z, there's Y, there's Z, and there's X. So like this. So B is equal to this. Now, B being equal to this, Z, Y, Z, and X. We see that Z is being repeated here. That means that Z is just a distinct element. What it means is we cannot have repetition of the same elements. It must have a distinct elements. So meaning the set B is just actually the set containing Z, Y, and what? And X. The order which I write them will not matter. It can be in any order as long as it contains that element. So because Z is just a single, there's only one type of Z. There's no other type of Z. It's just it has to be distinctive. So meaning that when we are following the elements in there, it means that if they are contained in A, the same elements, the order will not matter. If they are contained in B, then this set is a subset of that one. If B is contained in A, like that, meaning elements that are in B are contained in A, they are there, then all these two hold. It means that A and B is going to be able to be equal. So now, first of all, we must see that these elements or in these sets are actually distinctive. And you see where it's being repeated, Z, like B here we've sorted out, Z is distinctive, like you write it in this way where it is distinctive, where it's just Z written as one and not Z is repeating. You do the same even for C, because C is given as Y, X, Y, and Z. So we see that the Y is being repeated. So I have to write Y once. So I write Y once, X and Z. This way it is distinctive. And we see that that's how I have to list down my set. Then D, my D is, what's repeating also is the Y there. So I write only one Y, Z, and what, and X. Whichever I would choose, whether to write the one at first, the one at second, just it's Y, it's distinctive, it's just Y. So now, because of this now, they tell me now to say, the question is which of the following sets are equal. Now, when you observe all these sets now that we've written them in a distinctive format, which is B written like this, we have C written like this, and D here written like this. And of course, we have A in the question, which you already know is X, Y, Z. Now, remember that we are saying the order in which you are going to write your sets, your elements in that set does not really matter. As long as they have the same elements, then they'll be equal. And if we're to check, all these sets contain what? The same elements. And thus, we're just simply going to conclude to say, okay, somebody's writing on my screen. We're just simply gonna conclude to say that all these sets here, it be D, it be what, they are all equal. Okay. Let me disable something here. Okay, right. So if you have a question, you're free to ask. Yeah, but then we're saying all these three sets are equal. So what we're saying is A, therefore B, C, and D are equal, because they all contain the same elements. Right. So moving on to the next question. Next question now is where we're going to spend some time here, because this is actually the last question for the class, and I said the rest of the questions can be accessed on the website. So you can register, then on the website, and you're able to see what the rest of the solutions. So now, how do we do this one? So this one now tells us to consider the universal set. The universal set has been given to say this is U, and it contains elements from 1, 2, all the way up to what? Up to 9. And I'm just listing them one after the other. So I'm just listing those natural numbers like that from 1 to 9. Then now they're telling me the set A. So the set A is given as the set that is from 1, contains 1, 2, 5, and 6. So this is the set A. Now, the set B also has been given. That is the set containing 2, 5, and 7. That is the set B. Then I have the set C. So the set C contains 1, 3, 5, 7, and 9, like this. So this is my set C. Then now, they are asking me these following questions. What am I gonna do about them? So now I'm gonna solve these questions here. So to solve these questions, we're looking at intersection first of all. So remember, we ought to remember the definition of what we said intersection is, or the operator intersection does. So what it does is it brings or looks at what elements are common in both sets, and it lists down what those elements, then that would be that set. Elements that are common in both sets. So now they're telling me A intersect B. From the definition of what we've said, who can tell me what is in this, what is in our set here? What is in our set? What is going to be A intersect B? Anyone? Okay, since nobody's talking, we're gonna proceed here. And when we talk of A intersect B, looking at elements that are common in both sets here. So I go in my A, I can see a 2 here. I can see there's a 2. I can see a 2 in my B. So I'm gonna list that down here. Then I have a 5 there. I also have a 5 there. And I'll list that there. So this here is my A intersect B, because these elements are both in A and in B. Next, they're telling me A intersect C and A intersect C. I look at A and C and I look at elements common. There's 1 there, there's 1 there. So I put my 1 here. There's what other element? There's 5 here and 5 there. So I'm gonna put my 5 there. And that's it. Those are the elements that are common. So this here is my A intersect C now. So I have found my A intersect B and my A intersect C. Next, they're telling us to find the complement. So how are we going to do that? So complement, there's A complement and what? And C complement. So when you look at A complement, we're just saying the universal set, then I remove the set what? The set A. The universal set, then I remove the what? The set A. So my universal set ranges from 1, natural numbers from 1 to 9. Then my set A is here listed as 1, 2, 5, and 6. So what I'm doing is I'm just getting my universal set. Then every element which is in A, I'm going to remove it. Then what remains is my A complement. So if I see here, I have universal set listed as 1, 2, okay, all the way up to 9. So then I have my A here, which is just listed as 1, 2, 5, 6, like that. So I'm going to be removing now. So I'm subtracting or removing these elements that are in A. So one is in the universal set. So I remove that, it will not be part of my complement. 2 is in the universal set, I remove that, it won't be part of my complement. 5 is in the universal set, won't be part. 6 is in the universal set, won't be part. Which leaves me with what elements now? It's gonna leave me with 3 here. It's going to leave me with what? Leave me with 4. Then I'm going to have 7, 8, and 9. So this here is my A complement. So as we said, in other words, what we're talking of is all elements that are not in the set A, but sit in the what? Universal set. This is what we mean by A complement. All elements that are not in the set in the set A but sit in the universal set, and that's what we get here. So we do the same similar thing for the set C, and set C like that, and we're saying C complement. So my C is listed down as here, there, and I'm saying all elements that are not in C but sit in the universal set. I can see my universal set here, as I said, 1 to 9. So now, if one is in C, it's also in the universal set, meaning it's going to be my complement. I look at what element is not here in C but is in the universal set. I see 2 there. 2 is not in C but it's in the universal set, meaning it will be in my C complement. So 2 will go there. 3, okay, no. I go 4. So 4 is not in C. So 4 is not in C but is in the universal set. So I put my 4 here. I go 5 is there. So 6 is the next one. So I go 6 here. I look at the other one. The other one next is what is just going to be 8. And you see here, you just end up with a set of this is just a set of even numbers. Even numbers just between what? Even numbers between 2. This is included, and also 8 like this. That's if I wanted to write it in Z-beta notation. If I was ever asked to write it in Z-beta notation, I would write it, of course, to say C complement in this case would be the set of OX such that X ranges between 2 and 8, and of course my X is just what is an even number. Of course, I would then just include that it's an integer or a natural number, as I can see there. But the point that I'm talking here like this, you'd know that we're talking about even numbers like that. So I'd include here integers like that. So I mean natural numbers like that. So yes, so this here would be what would be my set. Or even writing here saying X is a member of what? Even numbers. Writing that there. So okay, now we move on to the next question, and the next question now involves the symmetric difference. So the symmetric difference, when talking of symmetric difference, here we've been given this sign just for symmetric difference, B, and the other one we have to find is A, like that, and C. So we start, of course, with this first one here. So in general, if I have two sets A and B, the symmetric difference is going to be defined as A minus B, or set difference, and here they are saying A set difference of B, then union, then you have B, the set difference of what? Of A, like that. And as you can see, this can also be written as what? As A intersect B complement union B intersect A complement, like that. So it can be written like this or like that. So from this is how now we're going to solve this question. So the difference of A and B is what we have to find first. Difference of A and B. So I have my set A and my set B there. So what I'm doing is I'm removing all elements that are in my set that are in my set A. If they're in B, if they're in A and they're also in B, those I'll remove, and I remain with those that just are in A. So what I mean is this. So I write down my set A first. That is 1, that is 2, that is 5, and that is 6. Then here my B. My B is 2, 5, and 2, 5, what? 2, 5, and 7. 2, 5, and 7 is my what? Is my B. So now after this, then I remove now elements that are what? That are in the set what? Here, that are common. So I'm going to remove them. So I'm going to remove the 2 and the 2 there, and I just remain with what in A? I remain with 1, I'll remain with 5 and 6, like that. Okay, so in other ways, as you could see here, it's written A intersect B complement. How would we think of that? So here, this here wants me first to find my what? To find my B complement. And from what I know or what is here, we see that our B complement, which of course can be denoted with this prime or with a C here, B complement, we're just saying all elements that are not in a set B but sit in the universal set. So B only contains 2, 5, and 7. So the rest, meaning that are not in that set, will be in the universal set. Then the ones that are list down in the complement. So that is 1, 3, 4, 6, 8, and 9. So this is what I'll list to be my B complement. Then they're saying my A. It's saying A intersects B. So what is my A? So if you look at my A is just 1, 2, 5, and 6. Then I'm intersecting these two here. So we are now then what? We're now intersecting these two here. So when we intersect, we're looking at what elements are common in both of these sets. So bringing the elements that are common, I'll have 1 is common in both of them. I have that, what element next is common? I have, okay, I'm having what? 6. Having 6, right? Is that the only one that's common here? So 1, I have 6 there. Okay, so my B complement contains 5. Okay, yes, I think that's what we get. So we have A here, like that, listed as 1, 2, 5, and 6. Then my B complement 1, 3, 4, 6, 8, and 9. Then when I intersect them, I get 1 and what? I get 1 common and 6 is common in both of them. So going back now to this part where we're saying we are removing this part and seeing what we remain with here. So when we removed 2, oh, we forgot to remove 5. Sorry, 5 here is in both sets. Okay, it's like people are not following. So 5 here, 5 is actually in both of these sets. So here we have 1 and 6 because you have 2 there, you have 2 there, you have 5 there, you have 5 there. When you remove this, if you remove this from what? From A, you remain with 1 and 6. And this is the other process now, which we got where we got A, intersected it with a complement, and we found it's 1, comma 6. So that's how we find what? Find that first part. So we keep this 1, 6. So I erase here down. Okay, I erase here, erase. Then we have, now we keep this 1, 6 as for the first part here. Then now we find B, set difference of B and what? And A. So it means my B here, this is my B, and my A is this one. So I remove elements that are what? That are common, is what I'm saying. So 2 is here, 2 is there, so I remove it. 5 is there, 5 is there, and I see what elements do I remain with. So I just remain with what we see, 7. 7 is what remains. So the set difference B and minus A, this is just going to be the set containing 7. This is what I get. Next, I just bring these together. There's union here. Union just means elements that are either in that set or the other one, or both of the sets combined. So what it means, they're just bringing every element together. So now I have this part and that part, and I just bring together. So it is 1, 6 union the 7, and this into one set just is going to be 1, 6, and what? And 7. So this here is the symmetric difference of what? Of A and B. See the symmetric difference of what? Of A and B, like that. That's how I find it. Okay, I don't know if there's any question here on how we find that one. Okay, there's no question. Let's do the other one here. So symmetric difference now between A and C. A and C is what we are finding. So we go the same A, I remove C, then union C, I remove A. So what do I get the first one? The first part A, I remove C. So my A is this one, my C is this one. So what elements are going to be common here? So from my A, there's one here, there's one. So I remove the one, I remove the one there. Okay, the next I have which one common? Well, I have a 5 there and a 5 there. So the 1 and the 5 have been removed, and I remain with 2 and the what and the 6. So that is what remains in what in A, and that is going to be my A minus C. So I'm going to have, okay, so I'm going to have 2 and 6 remain. Then the other one is C, A, like this. Okay, so this is my C, this is my A. I look at what is common that I remove. So my A, so in my A, I remove this. Actually it's the same, like you remove the 1, remove the 5, but what you remain with here, instead you remain with 3, 7, and 9. So in this case, you're just going to remain 3, 7, and 9, like that. Then from here now, yeah, union, bring everything together. So meaning the symmetric difference of A and C, everything together, I'll just have 2, 3, 6, 7, and 9. And just like that, that's how I find my answer. Okay. Okay, and I think this helps us to answer this part here. If you look at this question that comes here, this one here, we've answered it, which is just this here. The set difference is here. We found it. And we earlier found this one here. But anyway, let's just go through that again, just in case somebody did not understand what we are talking of. So we're saying A. So A, this is the set difference. Or, of course, it can be written as A minus B. Or this is equal to A intersect B complement. And further on, you'll see how these are the same when we do the proofs. Of course, not in this class. But then, so A, how we did, we said just list down your A, and your A is 1, 2, 5, and 6, like this. Then minus, then your B is 2, 5, and 7. Then you remove these elements that are common here. So I move the 2, remove the 2, remove the 5, remove the 5, and I see what elements remain in A, and it's just 1, 1, 6, and I've done that. And of course, similarly, how we did with what? With C, which we were just from doing this A minus C, we just did this one. So I see no reason to repeat that. Okay, let's now do the last question. So the last question, you have A. So the last question here is A union C, like this. Then the difference with what? With B. So of course, I can write my A union C. Let me find my A union C. My A union C just tells me get all the elements that are in A, get all the elements that are in C, and put them all together. So I have my elements, and of course I'll write them distinctively, not repeating elements. So I have 1 like that. 1 is in A, it's in B. I write 2 also like that. I write 3. I'm just combining all the elements. 3. I write 5 is in there. Then I write 6 is in there, 7 is in there, and 9 is going to be what is in there. So I've combined all those elements. Now it's saying the difference with what with B. So I just remove my B here. So my B is what I'm removing. So this here, putting my B is 2, 5, and 7, like that. So removing 2 is there, 2 is there, because 5 is there, 5 is there, 7 is there, 7 is there. Then I see, so A union C, set difference with the B. This is just going to, what remains in this set is 1 remain, 3 remains, 6 remains, and 9 remains, like that. So this is what I remain with. And as you can see, this is yeah, this is just what I remain with. Yeah. So the next one is the symmetric difference first. Okay, so symmetric difference, you can see here, they're telling us first you have B symmetric difference, C, then the difference with what? With A. So let's find this first. here like this, and this here we said is just equal to, this is equal to A intersect, okay, and let me not use the intersect one, but let me use A minus B, then union C minus what? Minus B. So the B minus C means B, I remove the common elements that I want, that are there C. So my B is this, my C is that. So let me look what's there. So 5 is here, 5 is also there. 7 is there, 7 is also there. And I see, what do I remain with? I remain with 2. So I remain with 2 in B, so I write this would be just equal to 2. Then I do the opposite like that. So I cancelled already. I cancelled the 5, cancelled the 7, 5, 7 here. So I check now, it's what am I remaining with in C. So in C, I just remain with 1, and I remain with 3, and I remain with 9. So this is my set difference here of A and C. Now to find the symmetric difference, to finish that up, I bring all this together because it's union. So this would be just 1, 2, 3, and what? And 9, like that. This is what I get. So now this is the first part. Then now I finish the question here. To finish up, they're telling us do the set difference with what? With A, what you found. So what I found here, the symmetric difference of B and C, then I remove what? My A. So this is my set, then I remove my A. So I'm going to have 1, 2, 3, and 9. Then I remove my A. My A is 1, 2, 5, and 6. Like that. 1, 2, 5, and 6. So I remove that. So I check what's common here. 1, 1 goes. Here 2, 2 goes. Then that's all. That's what remains. Then I see what remains in this, what I found to be my symmetric difference. What has remained is just a 3 and a 9. And just like that, I found my answer like that. And this is how I do these questions. Don't know if we have any questions, but we are done for the day. Do we have any questions? Did I leave anyone behind? Okay, no questions. So you can access the full video on the website. You can register via the link or via on our website, that is at discretelearning.com, and you can then pay for the course, and you find the solutions to this tutorial. All right, we'll see you in the next one.